We're now handing over to Brian Matthews, who's been leading the team at STFC, the Rutherford Appleton Laboratory in Harwell, who've been delivering the DAFNI system. So over to you, Brian.
Thank you, Jim. Yes, I'm going to go into a little bit more detail about what we are doing in DAFNI, what we've been trying to do, and I will do this quite quickly. Then this will set the scene for the rest of the day, for the demonstrations that we're going to give after this talk, and indeed for the talks this afternoon. So, yeah, I'm Brian Matthews. I'm the project lead for the DAFNI delivery and hosting team based at the Scientific Computing Department at the Science and Technology Facilities Council, working as part of the DAFNI consortium, working with UCRIT partners. So firstly, a little bit about why DAFNI, a little bit already. When we had our previous event 2 years ago now at Royal Society, Sir John Armitt came along and he said, data is now important, UK infrastructure as concrete and steel. And this is reflected in the reports we've seen, but also in this this report, Data Public Good, which came out 2 or 3 years ago now, which emphasised the use of using models and data to capture the independencies between infrastructure systems, so we can design infrastructure into the future, particularly in the notion of a digital twin, but also across the whole piece. So we need to use data, we need to use modelling for future infrastructure investment. And the UK has a world-leading place for this. We already have a lot of expertise, a lot of work has gone on already, and a lot of research projects across our universities to support this. So these are just some of the systems that have been developed by our partners. So we have a really good basis, a really good world-leading base in the UK to do this. But this still leads to challenges. We still have challenges for actually exploiting that research in the future. One is just scaling up. The problem is getting more difficult, just more data, more high resolution. It just gets more and more complicated to more complex models. So we just need to be able to scale up our models. And this may be beyond the capability of any particular research group. Further, as we've seen, interaction between models, integration of system models across sectors, across water, energy, transport, etc., and between those sectors and the economic and natural environments becomes more complicated. We need to work across those sectors and also at different scales, from the notion of a light of equipment right through to the whole country. So we need to be able to do that integration, which is essentially a data integration and exchange problem as much as a computational problem. We need to be able to share data. We need to be able to do that in a way that respects security. And so therefore we need common standards for interchange and interoperation. And this reflects that infrastructure systems research is essentially multidisciplinary by its very nature. We have to cross between environment, economic and social, and the engineering sectors involved in infrastructure. So this is where DAFNI comes in. So we're now talking about what the DAFNI program is trying to do. So, as Gordon has already said, so I don't need to say a lot more about this. DAFNI is part of the UCRIT program. In a sense, it is seen as an intersection between the other two parts, providing a computational infrastructure to support national infrastructure laboratories and urban observatories. And what we're trying to do is produce a computing platform for research and decision making for national infrastructure, and hopefully build partnerships across academia, government, and industry. So DAFNI itself is a partnership. We're involving 12 universities. So here are all the representatives on our governing board from the universities, and also from STFC, ourselves as a development and hosting partner. Because UCRIT is now 15 universities, so this was from the original 12. So we're working to extend the partnership to include them. So what are we trying to do? Well, we're trying to build a community hub. So DAFNI is a place where we can share data and models, we can bring them together, we can put them into one place where they can be shared and also combined together, exploiting a hybrid high-performance computing platform and with a repository for national infrastructure data and models, with a security infrastructure around that to respect the sensitivities and around that, around the use of the data. And this gives us a place to support collaborations. We can use our collaborative platform to build multi-systems models of infrastructure, to further research, and also as a legacy, a place to make data and models available for the long term in the repository, keep them executable and reproducible for the long term beyond the life of any particular individual research grant. So, moving on to the DAFNI platform, well, the foundation is a HTC hardware platform. So we have a dedicated HTC cluster with a reasonable amount of computing power available to it, and 2 petabytes of storage, so quite a fair hefty chunk of storage available to it. This has been set up as a Kubernetes cluster. This gives us certain characteristics, which I'll mention a little bit later. So we can the point is we can give more computing power to applications. And as Jim mentioned, there's also a number of hardware investments in universities, particularly in things like high-performance workstations and visualization equipment, which are coming online at the moment. And we're working to sort of integrate the central HD cluster with those. So that's the hardware basis of what we have. On top of that, where we spent most of our effort is in building a software stack on top of that. So we have been working on a number of different components, 5 main components being a national infrastructure database, a national infrastructure modeling service, a cloud environment, which is essentially part of the kind of fundamental infrastructure of the system, a visualization suite, and a security service. I'll go into the NID, the NIMS, and the NIBs in a little bit more detail. To mention security service, this gives a good ability to control access to data and to models, and so researchers can share with who they choose to, and not who they don't choose to, and within our security infrastructure at the Platform laboratory as well. Okay, to go into these in a little bit more detail, starting with the database. The database is a data hub, a data repository where we can deposit data, so it can be shared with topic communities, and also provide data curation. So one of the things that we particularly emphasize is the use of good metadata in a catalog, so that data can be searchable and discoverable in suitable ways. So this gives us a place for combining data and sharing data, that central resource where people can put their data, put their results, and share them with other people, and future researchers can come to it and look for super data. Though I would say that we don't necessarily say we'll hold all the data. Some of the data may well be held elsewhere in other data stores, and we will link to it, but then we can put it into use in our system. And then we have the modeling service. So this is kind of the core of what DAFNI provides. So the idea is that we can use the DAFNI system to essentially introduce models and code produced by anybody. So we use a system called containerization to allow users who develop the code on their own systems to upload the model onto the platform, independent of their code and operating system, by wrapping it up into a container, and then it can be executed on our platform in the security framework that we have. And this uses this system called Kubernetes for orchestration. They can then be scaled up for more compute. We can access the data in the database to make that usable, and then access the visualizations. And then we can then use the workflow system that comes with the modeling service to build more complicated workflows. So this gives us the systems of systems approach, where we can couple models together, we can chain them into sequences, or we can do them in parallel sequences and iterate together. and to produce more complicated systems of systems, and do that dynamic systems approach that Ottilie mentioned. And this gives us the ability to model, provide an infrastructure working across different sectors and different scales. And then finally, the visualization. The visualization is relatively new, so we have recently done this. This is a way we can produce visualizations from workflow outputs. We've done this a couple of ways. Firstly, a sort of interactive drag and drop tool where people can build graphs and plots and other visualization entities from the data. And we also support Jupyter notebooks for more for those people who are much more familiar with using code directly. So how's it being used? I'll run through this quickly, as most of this will be covered later on today. Jim mentioned an ISMOD system from the ITRC. So this has been one of our major flagships as a systems of systems model, and that's now supported on the DAFNI platform and is being used for such things as modelling the Oxford-Cambridge arc, economic development in the area between Oxford and Cambridge. We are engaged in a project called OpenClim, led by the University of Anglia. This is funded by NERC. So a EPSSC platform is now being involved in NERC projects. So we are showing that multidisciplinary aspect to the platform. What that OpenClim is doing is looking at the risks associated with climate change on infrastructure, things like flooding, health risk from extreme heat events, agriculture and biodiversity, and particularly looking at adaptation, how do we adapt our infrastructure to cope with that. This is using a multi-systems modelling approach. I'm using DAFNI to provide the framework, and Robert Nicol of University of Anglia will be talking about this later on this afternoon. We've also done some pilot work on digital twins, working with the University of Sheffield, with their urban observatory, taking data from their traffic sensors and an AI representation of the traffic flows in the city, and trying to do a real-time or near real-time model of this, so we can predict the traffic flows in the city 30 minutes in advance. And again, digital twins is something that we are increasingly getting engaged with, and Daniel Coker from the University of Sheffield will be talking about this later today. And finally, the Centre for Greening Finance and Investment, a relatively new programme led by the University of Oxford, to produce a national centre to accelerate the use of climate and environmental data by financial institutions to determine their investment strategies for infrastructure, amongst other things. And this, again, DAFNI is providing an open infrastructure accessible to the practitioners. And we've got David Wallam from the University of Oxford, again, talking about this later on today. So what next for DAFNI? Well, the exciting thing, as Jim's mentioned, is that we now have now moving on to our next phase, which we call DAFNI Rose, and which is a grant under the EPSRC's resource-only strategic equipment programme for the next 2 years, started last week. And this is all about building a community. So we're bringing our platform, which has been under development for the last 4 years, into production with an enriched collection of data and models. And the bulk of the work is going to be about developing the user base. How do we get researchers onto the platform and widening that use of the platform, getting a richer user base, particularly looking at things like early careers researchers. We plan to work with centres for doctoral training to provide training and expertise and give access to the platform for PhD researchers. And that sounds really exciting to me. We're also looking at further development on digital twins, as I've mentioned. Also, the information integration infrastructure, supporting some of the work coming out of CDBB. And again, Liz Varga and we'll be talking about some of the work around ontologies that's gone on the platform later on this afternoon. And we also want to produce multidisciplinary partnerships. So we're looking towards the long-term sustainability of DAFNI within the UKRI platform programme. DAFNI will be available for you, say, researchers, particularly researchers in the relevant research areas under EPSSC's priority areas, wide range of researchers working in urban and engineering systems and the built environment, and across EPSSC's themes. But we're also very much wanting to do multidisciplinary projects across research councils and with government and industry. We're setting up an application process at the moment, which will be overseen by our governing board, so people will have to say short case for use of the system, hopefully very rapid case. If this is for kind of regular use of the system, if we need larger scale use of the system requiring software engineering effort and changes to the system, we would very happily join in research projects and grants as partners to support your research. And for those outside those areas, and particularly government researchers, as Jim mentioned, we do have cost models based on resource usage and scale of use to support that. So please talk to us here if you're interested in using DAFNI further, finding out more about DAFNI and using the system. info@dafni.ac.uk is our contact line, or just visit our website or contact us. So finally, I'd like to really thank the DAFNI team. There's been quite a large number of people involved in DAFNI over the last few years. These are the current members of the team. So I'd like to thank all of them. It's been an incredible effort. We really could not have done this without this really talented team of people to do the work for us. So with that, I'm going to stop and pass on at this stage to who's next. Is it Rose next? Who's going to be giving? Sorry, Alex next. Alex next is going to be giving some of the starting the demonstrations. So thank you.